In this video, I want to talk about how to graph a rational function that is constant over linear. So our example here is f of x equals -3 over 2x plus 1. And so the first step in graphing any rational function is to find the vertical and horizontal asymptotes. So let's start with the vertical asymptotes. So the vertical asymptotes are when the denominator equals 0. So we're going to go ahead and say 2x plus 1 equals 0. So 2x equals -1. So x equals -1/2. So that means that when x equals -1/2, we are going to have a vertical asymptote. So let's go ahead and draw that. Let's do this. So x equals -1/2 is going to be right here in between the 0 and the -1. And that's going to be our vertical asymptote. And then we need to look at our horizontal asymptotes too. So when we have the degree of the numerator here is 0, and the degree of the denominator is 1. So that means that our horizontal asymptote is going to be 0. So it's going to be y equals 0. Because as x gets bigger and bigger and bigger, the top is going to stay the same and the bottom is going to get really huge, which means it's going to go right to 0. So we can go ahead and make this happen. Let's see. So our horizontal asymptote is going to be here, like that. Okay. Now we need to figure out where the graph actually goes within the asymptote. So we know it's going to get closer and closer to each asymptote, but we need to still know where that is actually happening. So let's go ahead and make a chart and let's look at some important values. So I'm going to look at what happens when x is -1 and what happens when x is -2. And then we need to look at what happens when x is 0 and let's try 1. So 0 and 1. So when we look at our y values, so -3 over 2 times -1 is -2 plus 1 is -1. So it's going to be -3 over -1. So that's 3. And then -2, so it's going to be -3 over -4 plus 1 is -3. So -3 over -3 is 1. And then when we look at 0, it's going to be -3 over 1, so that's -3. And when we look at 1, it's going to be -3 over 3, so that's just going to be -1. So let's go ahead and plot those points. So -1 is going to be 3. -2 is going to be 1. And then 0 is -3 down here. And 1 is -1. So what's happening here is you can see it's going up toward the asymptote here. And then it's coming down and going through this point. And then it has to go down toward its asymptote. So over here, you can see it's going down toward the asymptote, and then it's coming up to go through this point, and then again, it has to go toward its asymptote. Remember that it has to get closer and closer to its asymptote without ever actually getting there. So this is a sketch of what that graph looks like. It may not be 100% perfect, but it's pretty good. And so we can always see where the graph is going to go just by sort of leaning in toward our asymptotes. Once we know where we are on the graph, we kind of just go toward the asymptote, go toward the asymptote, go toward this asymptote, and go toward this asymptote. And that's how we graph a rational function that is constant over linear.